for the chi-square-test, it is also non-parametric test. Why it is non-parametric test? Basically, the parametric, it is related to the population. That means mean, standard deviation, median, anything won't be given in the question. That means the information of the parameters won't be given. So it is non-parametric test. Now, in all random trials, there exists some difference between the expected or theoretical frequencies and the observed frequencies. This difference is analyzed through a test called chi-square-test. This is why we do chi-square-test. Now the chi-square magnitude is given by M1, F1. We can replace F1 with O also, because we have given the name as observed frequency, so you can replace with O also. It is nothing but the summation of O I minus EI by EI, okay, the whole square by EI. So let us discuss this one. F1 minus E1, the whole square by E1. E1 means the first, E means the expected frequency, E1 means the first one. That we'll discuss during the taking up with the problem. F1, the same thing. So till what? Fn minus En, the whole square by En. So here we have to note one thing, that this formula is applicable whenever the summation of F1, or we can say OI, Fi or OI is equal to the summation of EI. That means the summation of the expected frequencies will be equal to the summation of observed frequencies. Then we can go for this formula. Now the next thing is that degree of freedom. It's the same thing, but the formula has slightly changed. That is n minus m. What is n? N is the number of frequency pairs and m is the number of quantities that are used in the calculation of expected frequencies. Always remember the m, at least it will be 1, because we are going to use this quantity. This is one quantity we are going to use. At least m will be 1. It might be 2 also in some case. We'll take up the problems and discuss wherever it will be 2. M will be 2 and all. So number of frequency pair depends upon the question, and so n minus 1 will give me the degree of freedom. Next, how to test the hypothesis based on chi-square test. Let us discuss that. E1 or EI, that means expected frequency, we have to find out. Then chi-square, that means this, apply this formula and find out chi-square magnitude, okay. Then chi-square C, you can see over here, this is the critical value. This critical value depends on degree of freedom and level of significance. Level of significance can be of two types. One is 0.01 and 0.05. This chi-square also contains one table from which we'll find out chi-square C, that is critical value. Then we have to see whether the chi-square which we have found out, whether it belongs to this interval. That means minus chi-c square comma chi-c square, whether it belongs to this interval. If it belongs to this interval, then we accept the hypothesis, otherwise we reject the hypothesis. This is the important thing you need to remember while testing the hypothesis based on chi-square test. So let us go for the problem. The problem is given: a die is thrown 60 times and the frequency distribution for the number of appearing on the face X is given as X is given and the frequencies are given, okay. So we have to find, this is what observed frequencies, we can denote with O also. So summation of this will give me 60. We have to find the expected frequency. So first we'll read the question. Test the hypothesis that the die is unbiased. So it is given the die is unbiased, we have to test the hypothesis. So always remember, if the die is unbiased, then the number of 1 to 6, the die contains 1 to 6 numbers, has equal probability of appearing. That means it has equal probability, means 1 by 6. Therefore the expected frequencies of each number will be what? Appearing will be in 60 throws. There are 60 throws, so 1 by 6 for one case, that is equal probability of each number. 1 by 6 into how many throws are there, that is 60, or the summation of the observed frequency, that is 60 by 6 will give me 10. This will be the expected frequency for all the cases. Now F we found out, it was already there, okay, F. Then E we just found out, that is 10, 10, 10, 10, all 10. Summation, you can see over here, it is 60. As I said, we can go for this formula chi-square whenever the summation of f and summation of e both are equal. So you can see over here both are equal. So as I said, E1, F1 and all, this is nothing but F1, E1, F2, E2, F3, E3, like that. Okay. So how many total pairs are there? 1, 2, 3, 4, 5, 6. 6 pairs are there. Therefore, n will be 6. So we'll come to that. First, we'll find out chi-square. So 15 minus 10, F1 minus E1, the whole square by E1 plus so on you have to do. Okay. This is not the whole square. This is 4 minus 10 the whole square by 10. Now you have to complete whole this table, this formula you have to complete and find out the chi-square value, which is given by 13.6. You can use a calculator and find out. Now we'll go for the chi-c square. For that we have to find the degree of freedom n minus m. N is what? The number of frequency pairs. Here you can see 6 are there, totally 6, that's why 6. And m is nothing but 1 because we have used only one quantity, that is summation of e and summation of f, both are equal. So we have used that. As I said, m will be at least 1. We'll see the problems where it is 2. Okay, somewhere we have to find the mean also, so that in that case it will be 2. So m is equal to 1, so 6 minus 1 is 5. So we got degree of freedom. Now level of significance is not mentioned in the question, so therefore we have to take both the cases, that is one for 0.01 and another one is 0.05. For 0.01 level of significance and degree of freedom will be 5 for both the cases. The chi-square c will be 15.09 as you can see on the table. Next, for 0.05 level of significance, chi-c square will be 11.05. You will see degree of freedom as well as level of significance. Now we have to check whether the chi-square, which is 13.6, whether it belongs to minus chi-c square comma chi-c square, minus and plus. Here you can see I have written both the cases because we have these two cases, that is 0.01 level of significance and 0.05 level of significance. So I have written both. We have to check whether in which 13.6 exists in which interval. So you can see that 13.6 will exist or will belong to this interval. Therefore we have to accept this hypothesis. We have to ignore this one, because you can see 13.6 does not belong to this interval. Therefore there is not this, we cannot take this case. Therefore we accept the hypothesis at 0.01 level of significance. We ignore this one, 0.05 level of significance, since the chi-square value does not belong to that interval. So we'll take up with the second problem. So here we have in experiments on pea breeding, the following frequencies of the seeds are observed. So you can see the following frequencies of the seeds. So round and yellow is given, wrinkled and yellow, these are the frequencies given. Observed frequency, it is summation is 556. Now theory predicts that the frequency should be in the ratio. Theory means theoretical values or the expected values. It should be in the ratio of the proportion 9:3:3:1. Test for goodness of fit between theoretical and observed frequency. What is goodness? Test for goodness of fit. It basically means that it is nothing but a non-parametric test that is used to find out how the observed values of a given experiment, whatever the experiment is given, is significantly different from the expected value. Okay. Now 5% of level of significance is also given. So we have to calculate expected frequency. So here it is given in the ratio proportion. So 9:3:3:1. So we'll add up all these things. We have to get some certain value. That's why we are doing this. So E1, how to calculate E1? First one, 9 by total number, add all this summation of this 16 into the observed frequency, that is summation of observed frequency is 556. That will give me the answer as 313. Just approximate this value, 313. E2 the same way, second one, 3 by 16 into observed frequency summation 104. E3 3 by 16 the same thing, 104. E4 1 by 16 into 556, which will give me the answer as 35. So we have got f which was given in the question. Summation of this is 556. E, expected frequency also summation we are getting as 556. Therefore we can go for this magnitude chi-square. So we have the formula. We have to just substitute these values f1 e1, f2 e2, f3 e3, f4 e4. Just substitute the values, you will get the answer as 0.51, which is chi-square. Now we have to see the degree of freedom, which is nothing but n minus m. N is the number of frequency pairs. Here you can see 4, and m, since we have not used any other quantities, so we have used only this quantity, that is summation of f is equal to summation of e, so it is 1. Okay, so 4 minus 1 is equal to 3. Now chi-square c critical value we have to find out from the table at 0.05 level of significance and degree of freedom 3. So you can see over here table, the value will be 7.82. Now we have to test the hypothesis. So chi-square value is 0.51, whether it belongs to minus 7.82 comma 7.82. Yes, it belongs to this interval, therefore we accept the hypothesis.